Okay, this is a sneaky one. So we've seen some examples where getting the right u and du can be a little bit challenging, but this one really kind of takes it up a notch. It's a good technique to see because occasionally it might pop up in some of the more difficult problems. So I wanted to make sure you guys saw an example of this now before so it doesn't just sort of totally blow your mind when it shows up later on in the course. So we need to pick ourselves a u here. And in this case, let's try the thing under the radical. So in this case, if we were to let u equal x plus 1, which means that our du is going to be equal to dx, let's see what that leaves us with as an integral. So now we've got the integral of, well, we didn't really take care of this x, but we do have the cube root of u and then a du right there. So we've got this lonely little x sitting here. Now, in this particular instance, if we were to notice that the statement that we have up here about u could be modified to help us get x in terms of u. So we're going to do a little bit of manipulation here. I'm going to subtract 1 from both sides, and we get u minus 1 is equal to x. So since this was our problem, we needed to get this in terms of u. So we need this in terms of u. This is going to help us do that. So now if we replace those two with each other, then we're going to have the integral of u minus 1 over u to the 1/3 du. Okay, now we've successfully removed all of our x's and dx's, but even still you might be looking at this and saying, well, I don't know how to integrate this. So the trick to this one, there's a couple ways you could do this, but what I would have you first consider is dividing by u to the 1/3 is the same as multiplying by its reciprocal, or u to the negative 1/3. And since these are just terms that we can multiply together, if we were to distribute those through, so if I was to take this u to the negative 1/3 and distribute it to the u and the negative 1, then all of a sudden what we have here is we've got the integral of, so we're going to add exponents we multiply, so u to the power of 1 times u to the negative 1/3 is going to give us u to the power of 2/3, and then negative 1 times u to the negative 1/3 is just going to be negative u to the negative 1/3 du. Okay, so now these are two terms that we can actually integrate. So if we integrate these each, let's see what we end up with. So if we add 1 to 2/3, it's going to give us 5/3. So it's going to give us u to the 5/3 divided by 5/3. And if we add 1 to negative 1/3, that's going to give us u to the 2/3 divided by 2/3 plus c. Never leave complex fractions like this where you've got fractions and fractions. So I'm going to, rather than dividing by 5/3 and 2/3, I'm going to multiply by their reciprocals respectively, and that's going to give us 3/5 u to the 5/3 minus 3/2 times u to the power of 2/3 plus c. And now lastly, before we walk away, we just do our back substitution, and we get 3/5 times x plus 1, because that was our original u up here, to the power of 5/3 minus 3/2 times x plus 1 to the power of 2/3 plus c. And it's not pretty, but it's ours. So we have to accept it. And that's our answer. You know, we could write this in terms of radicals. It's not something that I'm going to be particularly stingy on in terms of grading, but my math lab may show an example like this where you have to, or they'll use radicals rather than this. So just be aware that you can convert between these rational exponents and these radicals. So that does it for U substitution examples for this section. We will be using the technique of substitution throughout chapter 6 because other than antiderivative formulas, it's our only technique of integration. So it's definitely worth getting some practice and working through on these examples.